This unit deals with annuities. So if you think about an annuity, it's a repeated cash flow. So instead of the cash flows being uneven like we've looked at so far, every cash flow will have the same value. So our goal for this unit is to understand the concept of an annuity and distinguish between an ordinary annuity and an annuity due. We want to be able to calculate the present value of both types of annuities as well as the future value. And for this, I'm going to, of course, show you the financial calculator, but I'll also show you Microsoft Excel's approach to solving for annuity values. An ordinary annuity is one where you get your payment at the end of the period. The most common example here is your paycheck. You don't get paid in advance, you get paid after you do the work, so you get paid at the end of the month. A mortgage is another example of an ordinary annuity. We pay our mortgage at the end of the month. An annuity due is a cash flow or a series of equal cash flows that get paid at the beginning of the period. For example, many of you probably rent apartments right now. Well, rent is due on the first of the month, so you pay rent in advance of staying in the apartment. Anytime you lease something, such as a car or a TV or furniture, that's an annuity due. You pay for the good or the asset before you use it. The future value of an annuity can be found by taking each cash flow and compounding it till the end of the period. So let's look at this first. So it's the same idea as we had our uneven cash flow stream a few lectures ago. We took each cash flow and we compounded it out to the end of the contract or project, whatever we were looking at. The difference here is each cash flow is the same. So you have a common part to each part of the equation. Now, we're not going to get into the math of how we reduce this down, but it simplifies into one easy equation. So rather than taking each individual cash flow and compounding it out to the end, we can just do this one time, and it captures the value of every cash flow at the future value point. So the way we do this, we take the payment and divide by the interest rate, and we simply multiply by 1 plus r to the t minus 1. So this is the future value of an ordinary annuity. So cash flows you get at the end of the period. For example, suppose we put $1,000 a year in an account which pays 12% per year. We'll make 6 deposits at the end of each of the next 6 years. How much will we have at the end? So we could have done this with each individual cash flow like we did earlier, but this really simplifies when we use the future value of an annuity formula. So we simply take 1,000 divided by 0.12 times 1.12 to the 6th minus 1. Well, with a financial calculator, it's the same idea. N is the number of payments in the annuity, which here is 6. I is still the interest rate. We're not using present value, so we zero it out. Payment, I put negative 1,000 because we're investing the money, and we compute future value. Hit pause if you need to review this. Using Excel, we have a future value formula. And notice the terms are future value, open parenthesis, the rate is the interest rate, NPER is the number of periods, or N, there's the number of cash flows in the annuity actually. Payment is the annuity value, present value is what you start with, and then type is the type of annuity. So if it's our ordinary annuity where you get paid at the end of the period, type would be 0. If it's an annuity due where I make my first payment today or immediately, the type would be 1. Excel acts just like a financial calculator, so here, since I'm investing $1,000, I put a negative on the payment within the formula. Now let's go the other way. The present value of an annuity is the same idea as the present value of an uneven cash flow stream. Just here, all the cash flows or future values equal one another. So this formula reduces down into, we collapse in different parts of the equation into one value. Very easy to do. The present value of an annuity is simply the payment divided by R times our discount factor. And once again, T or N, T and N are interchangeable here in FINA 3000, is the length or the number of payments in the annuity. All right, for example, we desire to set an account that allows us to withdraw $500 per year at the end of each of the next 4 years. Our money earns 10% annually. What will we deposit now in order to cover the 4 withdrawals? So in other words, what are those 4 $500 withdrawals worth to me today? Here's the solution. Of course, hit pause if you need to review this for a while. We plug 500 in for the payment, 0.1 for our rate, and 4 since we have 4 payments of $500. We solve by hand and we get $1584.93. So conceptually, this is the amount of money I need in the account to withdraw $2,000 worth of money. The reason I need less than $2,000, you ask? Well, my account keeps earning 10% interest per year. So every time I pull off $500, my account still grows. On a financial calculator, same approach. N is the number of cash flows in the annuity, so that'd be 4. Interest rate on the account. Payment $500. Now here I put 500 in as a positive because it says we are going to withdraw $500 per year from this account. And we compute present value. Hit pause as needed. In Excel, we use the present value formula. Notice the nice thing about Excel is all the formulas are just alike. Here, for the present value function, it's just like future value. Just present value and future value have swapped spots if you look back in this file. So here it would be present value, the rate's 10%. NPR is the number of cash flows in the annuity is 4. Payment is our annuity value, $500 per year. 0 for future value. When we do this, the answer has a negative value, which tells you how much you need to invest or cash out of your pocket today to cover the withdrawals. Hit pause if you need to. Our other type of annuity was annuity due. So we get every cash flow at the start of the period rather than the end of the period. Well, think about conceptually why this is different. If I'm investing money and I make my first investment right now versus waiting a year to make my first investment, what's the difference? Well, the difference is if I invest today or start right now with my first investment, the money I put in right now has a year of interest earned before I make my next payment. So in other words, the annuity due, every cash flow is 1 period earlier than an ordinary annuity. That's the difference between starting at the beginning of the period versus the end of the period. Okay? So annuity dues are more valuable. How much more valuable are they? 1 period of interest. So if I want to compare them, to get the future value of an annuity due, I just take the future value formula for an ordinary annuity and I scale it up by 1 period of interest. So I'm just going to multiply by 1 plus R. That's all I'm doing. For the present value of an annuity due, you get the cash flow sooner, so it of course is more valuable. So we take the present value of the ordinary annuity formula and we multiply it by 1 plus R. So just think about it. Annuity dues are more valuable to us because we can invest sooner and start earning interest sooner. Here's a simple example. So we're renting a warehouse for 5 years. It's a rent situation, so remember, whenever you rent or lease something, it's an annuity due. You pay at the beginning of the period. So we're going to pay $6,000 per year at the start of the year. We'd like to set aside the money necessary to meet these payments. So our money earns 10% a year. How much do we have to deposit today? So it's the present value of an annuity due. So let's look at our by hand solution. So here we go for 5 years. We do the ordinary annuity formula. We scale it up by 1 plus the interest rate. So 6,000 divided by 0.1. We put in our discount factor and multiply by 1.1 at the end. So what this is telling you is if you set aside $25,019 today, you can support 5 lease payments of $6,000. And firms do this all the time. They set up accounts to cover debt payments on the horizon. And you use this annuity formula to figure out how much you need to set aside. Now to solve this on the financial calculator, our calculator doesn't know that it's an annuity due. We have to let it know. So the way we do that is we set it to begin. Now the way you set a TI BA plus to begin is you You use the second key. That's the colored key on your second row. Most times it's yellow for most versions of the calculator. So you go second and then hit the payment key. And what should pop up on your calculator is END for end of the period annuities. We need to flip it to beginning of the period annuity. So we just go second and then enter. And what should show up on your calculator now is BGN for begin. Now remember, this is like a light switch. You turn it on and off. So if you don't come back and repeat these same steps, which is second payment, second enter, your calculator will stay on annuity due setting. And that's not going to be good on test day. So be careful. So once you have it on begin here, then you just put in like it's an ordinary annuity. You'd say N is 5 for the number of payments, interest rate's 10, payment 6,000, solve for present value. If you're having trouble with a calculator, remember I do have a file up on our web page. It's sort of a calculator tutorial. Now in Excel, same approach here. We'd say 10% is the rate, 5 is the number of periods, 6,000 is the payment. But notice the type is 1 because this is annuity due. So it's the same idea. You got to let Excel know that the payments are at the beginning of the period rather than the end. So that concludes our annuity notes. Try to get on the Wiley Plus homework and work those examples, because with time value of money, repetition and practice is your best way for success.